The next thing I want to show you is the 3D printed cowlings fitted around the electric motors for the A-20. Alright, so I'm going to hold this camera in one hand. It's going to be a little bit awkward. Let's see if I can do this. Okay, there we go. That was pretty straightforward. I designed this cowling to split in half so that it can essentially be peeled off. Okay, I'm stuck on the propeller blade. There we go. So the cowling is two-piece. Magnets on both the vertical side where it splits and also on the back. See if we can get this into focus here. Alright, I know what to do here. Alright, there we go. Alright. See if we can. Having a difficult time getting it to focus on the magnet. So let's. Alright, there we go. Alright, so I manually did the cutout for the wings leading edge. It's a different size for each piece. Larger cutout on the inboard and the narrower cutout on the outboard. Okay, so the 3D printed cowl has some reinforcements. I tried printing the cowl without the reinforcements, just the line curving over. And what I found is that the print would essentially fall off the inside. So it was required to build in some supports, and that makes the front end leading edge of the cowl pretty strong. So now this is typical of 3D printing, or at least mine. And so the cowl is finished with a Bondo glazing putty and then primer painted. And then this was hand brushed. This is before I got an airbrush. So I hand brushed on the olive drab after the primer paint. Alright, so the point of all this is to allow easy access to the motor. Specifically, I usually need some kind of leverage on the shaft in order to be able to take off the nut, in which case is under the dome of the my scale-like propeller here. So the bulkhead or the nacelle bulkhead for the motor, it's got a lot of spaces in it, and this upper space is big enough for me to slip the electronic speed controller inside. Can't really see that, but it's in there. So there's generous amounts of air openings, and if I walk around the aircraft, just because it's closer, let's use the left side. There are vents for the air to flow out. So now it's not quite 20% greater area for the exit. Some of that exit space will be taken up in the main landing gear bay where air will exit. So between the landing gear bay and these two holes on the bottom of the nacelle, there is more than enough exit area for the air flowing into the cowl to keep the motor and the speed controller cool. Alright, so let's see if I can put this together one-handed as easily as I took it apart. Okay, that was pretty straightforward. So maybe I should mention here, this is a Turnigy G15. As you can see there, it's a 950 kV. Truth be told, I don't know that much about electric motors, and this looked like a good combination for this airplane. It could drive an 11.6 two-bladed propeller, which is what I was looking for. All right, now the cowl is back in place on the nacelle, and everything looks good. I've removed the hatches as I prepared to install the receiver so that I could then install the batteries and run the motors. So I'm looking inside the rear compartment, and there is a myriad of wiring. All right, so I'm just going to move stuff over here. Right here, these two connectors, I'm going to let go of them. See, they go back into the fuselage. Those are for the ailerons. Okay, and then I have additional wires running up through here. So this one that goes into the tied off bundle, this one here, is for the nose gear. And the final plug, oops, where'd you go? Okay, that one's, okay, this one's the rudder. Excuse me. This one is the nose gear, and there's two connectors here. So there's a Y connector right there going to the rudder plug. So this final wire coming through is for the bomb release. Okay, so that's what's bundled up here. So we have ailerons over here, then we have a Y-connected rudder and nose wheel, and then the plug-in for the bomb release. So I'm looking around. At how I have these wires set up, and I've pushed them down in. There's also, let's see, ailerons, bomb release, rudder, elevator. There we go. All right, this little junction box right here, it's not a junction box actually, it's a conduit. You can see the conduit going down the bulkheads, and it goes all the way to the tail. So I'm going to get a different perspective on that. There we go. That makes a lot more sense. So I've got three servos down there. One of them is on the rudder. And then I've got one on each elevator. Now, I would have liked a cleaner setup than this, but designing and building one of these takes a lot of time, and a prototype is exactly that, a prototype. So I figured if I was going to build something this interesting, the thing to do is get the basics correct and then work out the finer details later. All right, so as I was filming this, I puzzled out what my wiring harness situation is. It's been a while since I looked at this, so basically got to retrace everything. Currently, I am charging a small NiCad battery I'm going to combine that battery with the receiver over here. And this whole thing runs off of a 5-channel radio. So I've got the Spectrum DX5E here. It's 5 channels. So the basic 4 channels everybody knows about. It's got a landing gear switch, which I use for the bomb drop. And it's also got a dead man switch to use in the trainer function. Let's see. There's a plug-in for the trainer right there. And it's fairly simple and straightforward. The servo reverse is right on the front face. So I have 2 of these. I got to figure out which one actually goes with this airplane. So that was, just to summarize here, a quick journey through the wiring harnesses leading up to the receiver. And the receiver is one of the 2-part receivers. So I will be mounting the receiver close to the aileron plugs, and then the second part of the receiver I'll mount over here on the wall. Someplace where its wiring will be pretty much out of the way. And all of this will look a lot less scrambled once it's all plugged into the receiver. Okay, time to move on. After plugging in the radio system and checking everything, the ailerons are working fine and the rudder is working fine, but I've got no response from the nose gear and no response from the right side elevator. So I need to take the wing off. There's the bolts for the wing. I took them off with the Allen screw, although these guys are hex heads, so a socket wrench would do, or if need be, a crescent wrench. Alright, so what I need to do is check the wiring all the way through. These are the wires that go to the nose wheel. They are connected via Y harness up here to the receiver. Now I've checked both sides of the Y harness, and the rudder is responsive on both sides. So I've eliminated the Y harness as a source. Plugging the nose wheel lead directly into the receiver also didn't work. Neither did that work for the elevator. So the bolts are out. I'm going to be lifting the wing off. Comes up like this. I'm not going to attempt this with one hand, so this is not something I'm going to show on the video. I will lift the wing trailing edge up until it clears the bulkhead back here, and then I will slide it back very carefully. Okay, and the dowels disengage and the leading edge drops down into the saddle a bit. There are electrical harnesses for the servos. I'll have to take care of that. I need 2 hands. So I'll show it to you after I have the wing off. The whole thing is on a cradle. One piece of advice, I did this once. Don't take the wing bolts out when it's sitting on its landing gear on the table. The tail will just suddenly drop. The wing will change angle, and basically you have a big thud that makes you think everything's broken. Okay, so be back in a bit. Here's a look at the bottom side of the wing, and also how a cat tree can be useful for more than cats. Good place to put the wing. Alright, so what we've got here is power cables running out of the leading edges going to the motors. Or actually going to the speed controllers and then to the motors. Alright, here so we have the cables for both the ailerons and the speed controllers taped down so they're not all willy-nilly all over the place. And also on the speed controller leads, I put ferrite beads to cut down on any signal that might develop. All right, so we've got 4 wires coming out, 2 speed controllers, 2 aileron servos, and then the power supply wires going to the electronic speed controllers. All right, so now over here, this is the wing saddle area. That's the roof of the bomb bay compartment. You can see the servo right here for running the bomb release mechanisms. And let's see, these are the connectors for the ailerons. And then I've got the 2 connectors here for the speed controllers. So our culprit wire is the nose gear wire, and it's running right here. And so I had to take the wing off so that I could access that wire and try to figure out what's going on. So the nose gear, let's see if I can get a picture of it here. There's the nose gear servo. It's a detachable box that I use so that I could drop the entire nose gear assembly out if I have to. If I must, I'll do that. Hopefully I can find out where the problem is without dropping everything, but that's why I made it detachable, so that just in case I have to work on it, I can do so. All right, now the other side, the ailerons, I've got a few more things that I can check from this end, but there is, on the bottom of the fuselage, let's see here. There we go. A small, well, I wouldn't call it a hatch. I'll call it a patch hatch. It's basically a plug held in by a couple pieces of ironed-on covering. And that allows me to get to the wiring so I can check and see why this servo is not active. Okay, so time for diagnostics. This is where we are with the diagnostics so far. All right, so I've cut the 2 cable ties that bound the 3 servo wires coming out of the box conduit right here. Those guys are cut. I've also taken the servo arm, push rod, and clevis off of the elevator servo that is not functioning. Okay, so I've got this servo wire is now just about ready to go into the conduit. There we go. And I'm going to roll the fuselage over here. Very carefully. Fuselage is very light. The greatest mass is in the wing. So this is comparatively light. Okay, so I used a sharp X-Acto blade and cut off my little strips of covering that I used to secure this plug. And you see it's angled, and the little bay it fits into, the sheeting there is also angled so that it fits nice and snug. All right, so I've used a pair of tensioning tweezers, squeeze them to open, let go to close, to grab a hold of the wire and pull it this far out. Okay, if I pull it any further out, the connector is going to disappear down the conduit, and I want to be able to show you that first. All right, so I've got the servo out and hanging. There is, I don't know if it will be visible. Pardon me while I move things around. Let's see here. Okay, not really visible. But there is another small piece of conduit that goes from right about here to the root of the horizontal stabilizer. Now there's a couple things. If I need it, there's an open spot here that's covered with monocoat, the covering material, but right here, see it's a little bit springy. That's an open space where I can access the wires if I need to. And also, since I have the connecting rod disabled, it's a good time to show how these 3D printed hinges work with the elevator. Now notice the pivot point is back here. It's not on this edge. So this elevator control surface is pivoting just like the full-scale one would. And just like the access point that I showed you with the for the wiring on the servo, right there is another patch. You can see the reflected light off the open space. And here, there's a hole right there on the edge. And those go to a socket head 440 screw that attaches the, and actually acts as the hinge. It attaches the elevator to the elevator hinges. And there is a screw going in this way, and there is a lock nut glued in on the other side of the hinge. So this gives me a kind of a scale, realistic hinge for my control surfaces. And once again, the hinges themselves are 3D printed, and that was part of the design. Okay, so I'm going to continue with my Servo Diagnostics. I just need to pull that long cable out and figure out what happened to cause the servo not to respond. Okay, and most likely I'll just pull out the entire nose gear box. I already have the servo wire out. So it's 440 socket head screws. I'll just pull those out and pull the box out and figure out what's going on there as well. So I tried to make this as easy to maintain as I could given its complex design, and I'm hoping that I don't have to open up this access port right here. The less times I have to open up a covering, plastic covering port, the better, because to stick another piece of monocoat on top of what's there is just going to make that patch area thicker. So the option was to put in a more sophisticated kind of hatch, but on the first version, first prototype, there is a limit to how much innovation you want to put into a single model. So, okay, back in a bit. It turns out the problem with this side of the elevator was the servo. So, servo inoperable, not functioning. So I snipped the wires and soldered on a brand new servo. Now, these guys are not the best servos. I am doing this to restore operability to the airplane, but they're not meant to fly with these cheap servos. This is just what I've got at the moment. All right, so the servo has been threaded through. Let's see if we can get a glimpse of that conduit. Yep, there it is. Let me try to get There we go. All right. So you can see the servo wires are passing through a conduit there. And then deep inside here. See if I can get closer. Okay, so that's where the servo wire is coming out of the root of the horizontal stabilizer. You can see the, move this wire here. It's not gonna, there we go, we got some focus. That's the conduit for the servo rudder, or for the rudder servo, excuse me. And see if we can get some focus in here. All right, there we go. And right there is the 3 conduits for 3 sets of servo wires. The empty conduit is the elevator servo that I'm currently replacing. All right. So, pull back just a bit here. Flashlight. Gotta have a flashlight. All right, so my next task is to take this plug, thread it through the empty conduit. For that, I'll use my handy tweezers. And we'll pick this up when I get finished with this reinstallation.